Okay. Hi, everyone. This is the KubeVirt DRA support meeting. This is a CNCF recorded meeting, so please be nice to folks. And with that out of the way, is there anyone new around here who would like to introduce themselves?
Yes, I am. I am Andre Meyer from Wonder. We are doing a large implementation of KubeVirt, 15,000 bare metals, 60,000 GPUs. And we are here, as you see in the link, looking for know more about GPU live migration plans.
Hey, hi, Andre. Welcome. I see. Yeah, go ahead.
Yeah, so Nestor here from IBM and Red Hat, and looking for the DRA topic regarding the OpenShift virtualization in S390X architecture, since we may be interested in to enable S390X specific hardware in OpenShift virtualization. I would like to chime in and know the efforts that are going on, and just to get to know each other, because maybe we will collaborate together in the next couple of months.
Yeah, nice to meet you. What architecture again? Sorry, I missed that.
S390X, the mainframe.
Yeah, okay, I see. Perfect.
Yeah, hi. My name is Pavel. I'm from Mirantis. We are looking into deploying KubeVirt as a part of our stack as the virtualization for GPU deployments, in particular with NVIDIA hardware and on HGX and BGX platforms, and potentially on like NVL72 as well. So ARM virtualization and GPU virtualization with NVLink, things like that.
Awesome. Welcome, Paul. And just for everyone, we are going to be at KubeCon. So if folks are traveling, it would be nice to meet people there interested in DRA and KubeVirt in person. So feel free to say hi on Slack and we can connect at KubeCon. Okay, so with that, I think we can get started. So first off, I wanted to give an overview of where the DRA support is at. So we made an alpha release for the DRA support in 1.6. There were some issues and discussions that were pending before we can take this feature to beta. One of the biggest ones was that in alpha, there was a design choice that was made where the metadata, that is the PCI address and the MDEV address, were put into the VMI status. It was encouraged in the reviews that putting that in the status has a side effect of not being able to generate that data and encapsulate it in the Virt Launcher pod itself. So as part of that, there is an effort going on to provide a self-declared environment variable so that the launcher can, discover this value on the fly. And that variable is in the control of KubeVirt, and the DRA plugin authors don't have to, bind by a contract that we defined. So, this effort will provide a way where the DRA plugin authors don't have to do anything specific to KubeVirt to provide support for their devices, and KubeVirt and Kubernetes will read data like the PCI address from the attributes and directly populate that environment variable. So I think I would like to, take the opportunity in one of the future meetings to go and dig more into the design details here. But that's like the 5,000-foot overview of where we are. Once progress has been made on this particular design, I think that would be the biggest blocker for getting to beta. That and another is an actual driver support. So we are working on experimental feature with the NVIDIA Kate's DRA driver, which will have VFIO support. So once, but that will be behind a feature flag. But once that is available, it will be, available for folks to try at an alpha level. So combining these two things, I think it should put us in a good shape for considering this web for beta. That's the overview I had. I want to pause here if anyone has questions around this.
Yeah, I like the NVIDIA DRA driver. Is it going to be so? I mean, I think KubeVirt would need to provide something in terms of some kind of a default implementation for DRA. What are we going to provide there? Are we going? Do you expect KubeVirt to provide some kind of a generic driver, or do you want us to, kind of shift into providing the NVIDIA DRA driver as default?
So when you say KubeVirt has to provide some kind of a default implementation, can you talk a little bit more into the details? Like,
yeah. So for example, today when we use just regular device plugins, right? So we want to implement GPU pass-through or any other device. So KubeVirt has a built-in device plugins, right? So in general, you don't need to do anything special. You just can list your own hardware. It will, if it's there, it will be discovered, and then we'll start the device plugin for it. And any user by default can achieve this functionality. So if there's a GPU that's on the right assigned to the right driver, we can provide it to the guest. And when we look at what we implemented so far with DRA, we have the API, but we don't have the actual implementation, right? I mean, the driver is missing. So my question, so my question is mimicking the same behavior with the device plugins. Do you think that KubeVirt would need to provide a generic DRA driver, or we would need to reference something existing?
I think it would be ideal to reference the NVIDIA Kate's DRA driver for all devices related to NVIDIA and GPUs, right? The reason being, we have, so compared to the device plugin architecture, DRA architecture provides a lot of additional functionality, stuff like partitionable devices and admin access and other things, right? So to me, having that all of those features be implemented in the NVIDIA DRA driver will be the closest from maintainability perspective. So I think that's the preferred approach as of now, unless there are issues with that that you think we should not go down that route.
No issues. I'm just curious if it's so you're saying only for NVIDIA related devices, right? I wonder how will we identify those at the beginning. Yeah, I don't know. We don't have to resolve it now. Just a thought that I had, because we had some kind of a generic template for KubeVirt with the host device pass-through right now. And I thought, like, how do we start with do we'll have something generic, or we'll have to implement per vendor?
I
Yeah.
think per vendor would be the preferred way with DRA. We could come up with an example driver which can give folks a reference of where or how to implement this that we can support in KubeVirt. But I'm not sure with DRA it would make sense to have a generic implementation.
Yeah, maybe example is fine. Yeah, but this is something that to keep in mind when we want to move from alpha to beta as well.
Okay, yeah, that's a good point. Let me add that.
Yeah, well, Ale, I guess yeah, that's a good one to add. I think really the question, like thinking from the community perspective, like, well, like what kind of went into developing the generic device plugin? Like, what were all the motivations? And I guess what comes to mind is like I think, like when we look into the future, like there's going to be vendors that develop these things, and there'll be communities around those things, and so those things will develop sort of independently. So I mean, I think what it comes down to is like, to start out, I think it probably makes the most sense to go with and use the NVIDIA driver, and then depending on how things develop with communities here in this project and then the direction it goes, I think that would be like a question as to we could take later, like if we want to or need to have generic drivers, or is the community rich enough, like between all the device drivers out there that and all the vendors out there that that they can support all the use cases for the KubeVirt community.
Okay, yeah, that makes sense. Yeah, I think there is a hand raised. Nestor?
Yeah. So, related question. So that means that the idea will be that every vendor, so that means that every vendor provides his own driver implementation, which of course makes sense from the KubeVirt perspective, because you don't know all the drivers and you may not have access to architectures. My point is, as a state of now, I see there is an enhancement and so on. As a state of now, if a vendor wants to develop a driver, does it work as a state of now, or this
Yes.
alpha? So we have an alpha feature. That means that if we develop a driver, it will work, given that we
Yes.
have the
No, the current state is that it will work. The APIs provide two different types of devices, which is GPU devices and host devices. Internally, the driver has to have a specific attribute, either the PCI address or the MDEV UUID. As long as your devices can be configured in libvirt with those two addresses, it will work with the alpha feature.
Okay, and that means that it's GPU and MDEV devices.
I'm sorry, can you go again?
GPU and MDEV devices are the two ones that are supported.
Yes, so specifically the VFIO and PCI address devices, or the MDEV kind of devices, yes.
Okay, then. So that means if we have another kind of device, we will need to add it to this alpha feature, so to speak.
Yes, if you have another kind of device, I think it should be brought up in the web or through an issue immediately. When we were designing this, the only two devices we found were MDEV and VFIO. So that's where we started. But if you have other kinds of devices, please go ahead and create an issue of it or something like that, so we can track it along the feature lifecycle.
Yeah, but I have the information that I need. I guess I will ping you offline if I have more questions related to this topic. Yeah, thank you.
Okay.
Can I
I'll
say
lay,
something?
oh, sorry, go ahead, Andre.
I would like to also ask if someone is already working also with the Nouveau drivers, because perhaps we can also use open source drivers to achieve same functionality.
I'm sorry, your voice cut off. Which driver was it again?
I put on the chat window the Nouveau drivers that are for NVIDIA GPUs, but they are completely open source drivers.
I see. I don't know the answer to that question. Let me take that question and get back to you.
Great, thank you.
Like, so what I wanted to add, I think there was a question about the example DRA driver. I think there's an like an upstream example of this somewhere in that Kevin worked on, right? There's an example driver somewhere.
Yes. There is a driver, example driver. Let me bring it on screen here.
So where I was going with this, do we want to maybe like, I don't know if, or actually would be good to know if like, if KubeVirt can fit into that example, or if we need to make a change there. Because I guess where I'm going with this is that we probably don't want to have an example driver hosted in KubeVirt, at least not yet. We can probably get it here. That might increase visibility.
Yes, so we can definitely add KubeVirt related attributes to this driver. And once those attributes are there, this driver could potentially work. However, what will happen is these are just mock devices, right? So when libvirt starts to configure those attributes and starts to run the DOM XML, that DOM XML will not come up.
I'll have to look into this, but I wonder what is the what's the limitation?
So the way this driver works is that it creates like 8 fake GPUs. Those GPUs don't exist in your nodes. It will just fake them out and provide like attributes of those GPUs, just as an example, right? And when you try to allocate those devices, it will just populate the CDI spec, but there will not be any device behind it to realize that spec. So when libvirt when KubeVirt uses this device and Virt launcher tries to populate the DOM XML, that DOM XML, libvirt KMU will not be able to realize that DOM XML. So it will fail there.
Yeah. Yeah, I wonder if we can come up with something generic that KubeVirt populates what's needed to be allocated. I guess the same way as we have today with the generic implementation. I'm worried about the generic one because it will attract people to test the API better, I guess. But yeah.
So I think we are conflating two ideas here, right? One is the example. So I think what Ryan was mentioning was using this example driver to just point people at how to write your DRA plugin, right? That's one part of it. Then the other question is whether we want something generic or vendor specific. I think we can host this discussion in a separate agenda topic. I would at least like to see more than one vendor come in and, try to write a driver and find some commonality between what is being implemented across multiple vendors. And if that commonality for KubeVirt exists, then it might make sense to, start with something generic. But until that happens, I think having vendor specific will be the most maintainable way to go about it. At least that's the perspective I'm having right now.
Yeah, well, we can defer to later. That's fine.
Yeah. Okay. Yeah, Ryan, does that answer your DRA example driver query?
Yeah, it's for like documentation purposes, like in getting started. I mean, because we're kind of what we're talking about is like we said we want to build a rich community around people with their devices and using them in KubeVirt. So, I mean, there's several. I don't know how many vendors are out there, but I was just trying to say, like, I think there was a question about like should there be a KubeVirt example? So I think we probably want to go into this repo and have the KubeVirt example be maintained there in this DRA example driver repo.
Yeah. Yeah, I think this sounds like a good idea. Do we want to file an issue for this? Will that help? It seems like this is a separate effort from all of the things we need to do in KubeVirt itself. And I think having an issue will help gather thoughts.
Yeah, I think that makes sense. I wasn't aware of like what you were saying with the mock drivers, but I mean, at least from my perspective, if we can get any sort of visibility into people using DRA and KubeVirt, and then people aware that it's been released and it's an alpha, I think that's just better for the feature. So that's what I had in mind here. Is anything that could get us the visibility and people using this building drivers is going to be good for the feature.
Yeah, makes sense. Yeah. Okay. I think that's all I had on this topic. Anyone else want to chime in before we move on?
So yeah, I get the question. So we're working with these NVIDIA HGX platforms for GPU virtualization, but one caveat that they have is that there's also NVSwitch, and all like each of these machines have 8 NVIDIA H200 GPUs, but they are NV linked. I'm able to partition that NVSwitch. Let's say I want to put like 2 VMs, 4 and 4 GPUs. Schedule them on this particular host, but for that I would need to partition this on the switch, and there is like a Fabric manager client that does that. But it also introduces an interesting problem. There are finite combinations of GPUs that I can like do on these machines. Finite partitions that I can do on this NV switch. And in my mind, like something like a DRA driver should be aware of that. Picking the limitation or like conditions that I need to hit to fit into a particular NVLink partition. So the question is where that is supposed to be implemented. Is it like a separate DRA driver, or is it should be implemented in the NVIDIA DRA driver? Because I need to be able to pick specific GPUs out of a specific NV switch partition. Yeah.
Yeah, I understand this problem. It is something that I think should be implemented in the NVIDIA DRA driver because a lot of the logic around figuring out the devices will be reused. And we already have plumbing put into place to support KubeVirt there. So I think that's where it should go.
Well,
But
the alternative, I guess, is to have like a separate driver, and it exposes like these NVLink partitions as devices, like maybe fake devices, but sure, like devices, and something happens when I schedule them like that. And that logic is connected to GPU scheduling as well, but I guess that's more awkward than doing everything in a single driver.
so when you talk about the NVLink stuff, right? That would be NIC DRA driver, but I don't think the networking DRA driver is a prerequisite for supporting these devices in the NVIDIA DRA driver, right? Like, so there are, if you take the layered approach, there is like a very bare bone case of use cases where you can support these devices just from the GPU perspective. And then once that support is enabled from GPU perspective, you can add additional complexity around CPU and NIC devices. But I think to begin with, we'll have to put that support in the NVIDIA DRA driver, and then as support for networking and CPU driver comes in, those all can be leveraged with the DRA APIs.
Yeah, and like you mentioned, like the CPU and NICs, the scheduling constraint is actually much more difficult. Yeah, not only I need to fit into specific NVLink partition, I also need to hit like a specific NUMA node. Yeah, select GPUs from a specific NUMA node that matches the partition, and also pick up the correct like InfiniBand device that lives in the same NUMA node at the same time, and maybe like one more, I don't know, device like NVMe that also needs to live in that specific NVMe. I mean, NUMA node. Yeah, so quite a difficult scheduling situation.
No, I think what you express is correct. And I think we are working with the Kubernetes community to make sure that all of these attributes, the NUMA node attribute, the PCI root complex, the PCI address, all of these attributes on a device get standardized from the Kubernetes point of view. And once we have these standardized attributes, scheduling them from DRA APIs will be very easy. You just have to match those attributes on the value of the PCI root complex or the NUMA node, and Kubernetes will be able to schedule the workloads accordingly.
Because that's the biggest problem that I have right now. When I'm scheduling, I actually don't have that information. Yeah, my VFIO device gets picked quite randomly. Yeah, and
Yes.
I need like specific GPUs with specific PCI addresses, or like some kind of logic that would do that for me. Yeah. All right.
No,
well,
I think these
if
use
things are
cases.
coming, that's good.
Yeah. That's what I was trying to conclude. I think these use cases are being actively talked about and being discussed with NVIDIA folks. I think there are some Red Hat folks also interested in this. So I think we will have a plan for this pretty soon.
Any relevant tickets you can point us at, so at least we can take a look, maybe form an opinion as well.
I don't have a ticket as of now. As soon as I have it, I'll try to bring it into this agenda and discuss it. That's helpful.
All right. So yeah, thank you very much.
Okay, thanks. I think we can move on to the next one.
Yeah, I think in general these are the same problems that a lot of folks are experiencing, and maybe what we need is really some kind of a folder with all of these things that we need to track, so that when they will fall in place, we'll know that these scenarios are supported. And
yeah, actually, I was thinking of just utilizing this document and add things here to be
Yeah, sounds good. Yeah, absolutely. Yeah, because the next topic is like the CPU DRA driver support is also something that we're waiting for.
Yeah.
But here, here it's actually the DRA driver, the CPU DRA driver is not entirely ready yet. But I want us to somehow to start thinking about how we want this to look like from KubeVirt perspective. So today we have already the CPU struct with the dedicated CPU placement, and we request how many vCPUs do we want, sockets, cores, threads, and then in there we also have the additional threads for whatever IO threads we need, and then we also have this tunable for guest and NUMA pass-through. And basically we have all the controls, and the question here is how we want to express, how we want to use these controls and express from these controls a reasonable claim, or we want to go the other way around and present a claim, and then from this claim derive a control, which will be tricky. And in general, as I think about this, both ways will be tricky. And my preference, I think, at least for starting, I would prefer to start with something that KubeVirt already has, and at least use the existing controls to create a claim. But then I wonder if we will not shoot ourselves in the foot by taking this approach. So open discussion, I guess.
Yeah, I think the prerequisite of doing this, which is using the existing API to create the claim, is to check whether whatever feature parity we have in the API in KubeVirt is present in the CPU DRA driver as of today, right? Once we think that feature parity exists, then it might be possible to create a realistic claim out of it. Although I accept that this is going to be tricky, especially because we have moved from traditional Kubernetes resources, like native resources, to a declarative kind of dynamic resource, right? So it will be tricky to realize this spec through the resource.
What I was thinking about is that we could, I think the basic alignment exists. So we could create a basic claim from what I've seen, at least initially. But then if there are nuances, we need to have some kind of a way to express these nuances. And then the problem is that once we, so the problem is, around things like quota and other things that KubeVirt supports, which can be external to whatever quota Kubernetes is using.
So I think the quota aspect of it does have feature parity. So all the DRA APIs right now, they have quota built into them through the use of device class. So if you use the device class, then if you use a specific device class for the CPU DRA driver, then you will be able to define a quota for CPU resources.
Okay. All right. By the way, do we have any kind of influence over this development of the DRA driver, CPU DRA driver? Is there anyone from NVIDIA involved in this?
Not so. I have an eye on this project. I was thinking of getting involved. It is being worked on in the workgroup device management, and I represent KubeVirt use cases there fairly regularly. So it should be straightforward to get our particular use cases bubbled up into the requirements through that meeting.
Great. So the next question, I guess, is do we want to build some kind of an alpha version where we test these scenarios with existing API that we have with DRA?
Yes.
Yeah. So perfect. Cool.
Sorry, I was just taking notes. Yeah, I think to me, it definitely makes sense to start exploring this and find out gaps and report those gaps to the project through issues or through topics in workgroup device management meetings.
Yeah, I think that maybe we can create some kind of a periodic or I don't know, some kind of a non-voting job that we try to combine everything that we have right now, and so we'll be able to see some kind of a feedback.
The job in the sense, sorry, I don't follow.
No, in KubeVirt CI, I mean.
Ah, I see. Yeah, makes sense. Let me ping you regarding this offline. I think I don't understand what kind of output you'd like to see from this.
Okay.
Yeah, but let me take an action item to sync with you on that.
No problem. I mean, in general, I just want to see everything deployed and that we could use both of these drivers effectively. Sorry, Igor, I see that you need to. Do you want to go now and talk about that, or do you?
Yeah. Hi, folks. You can hear me well?
Yes.
Yeah. So just going briefly. So we have this web number 60. It's about passing PCI multifunctional device to KubeVirt virtual machine. And well, the issue that we tackled in the current KubeVirt device plugin approach is that it was hard for us to represent like a cross-device dependency, because like each logical function, we think of it as a device. And if you want to know why all the logical function must be passed to the virtual machine as a whole bunch of devices and not be allocatable, you can read the limitation in the web. It's basically about a CPI reset that can happen. So it's not good where if one device will be allocated to one VM and another to another VM, you can experience bus reset. So we found that we probably can solve it with the DRA driver. I was also consulting with Ally, and I will publish soon a draft design document how we see this solution. And the good thing is we can utilize the current DRA alpha state of KubeVirt in order to solve this PCI multi-device pass-through issue. Yeah, so that's basically a short update, and more details, as I said, I will publish some public document with the solution how we see this integration. But I can say the only drawback is that too much information on the user needs to be plotted, because we want to represent each logical function of the PCI as a host device in the VMI API, but we do refer to the same resource claim. So basically, we don't need to create resource claim per logical function. And this is basically bad, because currently DRA, they don't support cross-device dependency on the resource claim, inter-resource claim dependency. But what we managed to find out is that using once again a sophisticated resource claim template, which currently needs to be also provided by the DRA as part of that DRA driver. The resource claim template will describe each logical function in the device request, and this device request will be correlated to the host device in the VMI API. But once again, I think it's too much details for you unless you are already familiar good enough with the VMI DRA API and with the resource, with the DRA API as well. So we managed to find the solution. I tested it on the Kubernetes DRA example driver. So yeah, I managed to allocate multiple devices using this multiple device requests, but they belong to the same resource claim. Yeah, so basically that was a short update. Once again, if you, yeah.
I have some thoughts. So if you can, in the document that you are referring, if you can talk a little bit about the problems that you're facing from the DRA API, I think that will be very helpful to figure out why this is not usable. So there is two aspects of the usability part, right? One is that is the API good enough to support those use cases? And then second, is the UX around this ideal? So if the UX is not ideal, where it is too verbose and the API expresses too much, I think that problem can be solved using an opinionated approach in KubeVirt itself, right? But the first problem is not solvable. So if you can talk a little bit about what problem we are facing and have a follow-up conversation, I think that will be very helpful.
Yeah, sure. No problem. Yeah, and thank you for the feedback. I will do so.
Okay.
Yeah, that's it. Thank you.
Thank you. Okay, awesome. I think if nobody has more thoughts on this, we can move forward with the next topic, GPU live migration.
Yes, I saw this article here explaining about the future use case of live migration. No, on the top, the other link, and is related to DRA. And this is why I came to this group here to understand a little bit more what stage we are and how far we are from having this, because this is a functionality I must have in my solution. Okay.
So I think from what go ahead, Larry.
Yeah, I think what we're speaking of is a vGPU live migration, and not GPU at this point.
You're correct. It's vGPU.
Yeah. So in order to implement vGPU live migration, what we need is a mechanism in KubeVirt that would correlate the devices that we are allocating on the target to the source. So when the device is actually migrated to the target, it will be able to reuse the devices that are there on the target. But as it is today, the mechanism that we have in place is a little bit cumbersome, because it's the source that needs to communicate, that needs to modify the XML that will be presented on the target. And we want to change this mechanism into something that will be able to modify the domain XML on the target itself. And for any of this to work, KubeVirt needs to implement a new mechanism. And this mechanism is being currently developed. It's not really related to DRA. It's just a part of KubeVirt live migration process. But then, of course, the DRA would need to support allocating these devices.
Yes, my goal there is also to, for you understand, I start a VM with a slice of 2 gigabytes of GPU and VRAM, and now later on I want to change to 16 gigabytes of and VRAM. Without shutting down the VM, I plan to do the hot plug also. Did you think these also can handle the hot plug of GPU also, or this is a separate effort we need to do?
Did you say NVRAM?
No, the vGPU live migration can be enhanced to also do hot plug.
Yeah, no, I don't think that this is related to hot plug. Well, at least not in this scenario.
But you understand what I'm trying to achieve, correct?
Not entirely sure. You want to switch from one
I have a
VGPU to
VM
another?
with 4 virtual CPUs and 4 gigabytes of RAM and 2 gigabytes of GPU. A profile that I have on NVIDIA Q2.
Okay.
Now the users want to have more performance. I change to it's available hot plug on CPU and memory, but it's not available hot plug for the GPU. I plan to also add more CPU, more memory, and also more GPU, or exchange the GPU to a bigger slice. Instead of Q2, use Q6, Q12 or Q16. Okay.
So let me take a stab at answering this. So for that to work without downtime, you would need that feature to be supported in the pod itself, right? Currently, pod API does not have a way for you to hot plug DRA devices.
Can you explain PAR? What is PAR?
A pod, like Kubernetes pod.
Oh, Kubernetes part. Got it. This is something that need to be developed first on Kubernetes and then ported to here.
Correct. If the solution is intended to not take a downtime, if you are okay with
That's the
living
goal.
with it downtime, yeah, I don't think that is in any realistic time frame in upstream Kubernetes to have hot pluggable DRA devices.
Okay, let's work on that.
Nestor, I think you have a hand raised.
Yeah, thank you. Just for me to double check, I have first of all an understanding question, and second, more question related to our goals here. The first question is that just to double check. That means that in the case of live migration, we right now it's a little bit complicated, but to do live migration per se and with DRA. But the KubeVirt people, KubeVirt folks, another team, is working on a mechanism to just to make it easier, life easier for us, correct? Or life easier for everyone.
So live migration on KubeVirt is supported already.
Yeah, I know. That's but we're talking about new mechanisms to solve the problem because it's cumbersome, and I'm reading because the source needs to talk to the target and so on and so forth.
No, this mechanism exists because, for example, if you have a CPU pinning and you want to migrate your workload to a node with different CPUs on the target, then you just need to remap and remap the CPUs and then communicate it to the source, and then the source will need to recreate the target domain XML, and as part of the live migration process, communicate it to the target. So then after live migration, it will be all mapped correctly. We need to implement the similar mechanism for vGPU devices, which we don't have. But extending, so there are two ways, either to extend the current mechanism or come up with a different mechanism. And the different mechanism would just work on the target without all of this communication thing. And my preference would be for the later, and this doesn't exist and needs to be developed. And even the adjustment for the existing mechanism also needs to be developed. So that's it has nothing to do with DRA.
Yeah, I know. And yeah, and it makes total sense also from your point of view. And it makes also sense because if you are adding in the source, you need to adapt the domain XML and then transfer it, so it's cumbersome. Now I am getting it. But you read is this new mechanism is being developed, is a proposal, is an alpha.
There is an issue open with this. With the, I didn't see the proposal yet, but we are before the beginning of the 1.8 development cycle, so there's still time for proposals to arrive. So I'm pretty sure that there will be a proposal for this.
Okay, now I'm getting it. So then it comes to my question. So we are trying to bring a new device to the table, not GPU related. And for us, it's important live migration. What I'm hearing from you is that live migration, you are trying to take care of. There's efforts to try to take care about live migration. So it doesn't, from our perspective, it would be nice to collaborate on that. So, yeah, and focus, and we have two focus. We have the driver first, and then the second focus, the live migration. But that will be a future feature, or do you plan to have live migration with the release?
So let me just take a step back. I think live migration in general is supported already in KubeVirt.
Yeah.
And it's supported for if you have devices that are implemented in memory, then you can live migrate them. For GPU, for a physical GPU, that device state is implemented inside the device itself, and the device is being passed through to the guest using a kernel module that's called VFIO PCI, and that specific driver doesn't support live migration. For vGPU, these are implemented in memory, at least some of them. Then with the support from NVIDIA, from the NVIDIA driver, we can live migrate them because the NVIDIA driver supports this in memory transition. So none of this is related with the DRA mechanism, because DRA mechanism is only allocating devices for us, allowing scheduling and allocation. And if your device, I'm not sure what is it. If it's just a generic PCI device that will be supported with the VFIO PCI driver, then we're not able to live migrate it. If it's something else, then maybe it supports live migration, maybe not. I don't know.
Okay, thanks for the clarification. I have homework to do.
Sure.
And about the NVK drivers, on my mind, this is something that we must work also. DRA support for NVK drivers, because it's an alternative for proprietary from NVIDIA drivers.
Yeah, so I don't think support for this is currently planned. If you, yeah, I'm not sure if this is planned. I'll take an action item to get back to you. This.
Thank you so much.
Okay, awesome. So I think with that, we are coming to an end of agenda items here. I think we have some follow-up topics. So yeah, this is a bi-weekly meeting. So unless folks have some last-minute topics, we can call it here and meet again in a couple weeks.
Yeah, thank you very much, Ali, for organizing this.
Have a great day, guys.
Thanks.
Thank you.
Bye.
Thanks,
Bye.
folks.